See, y'all know more than you think you do. All right, what about this one? There's how many carbons here? 5 carbons, right? 5 points. The pentagon. So it's pentane, but it's a cyclo compound, so it is cyclopentane.
Can you show the answer for that? Just so I can. So I meant like with the little things around.
1, 2, 3, 4, 5 carbons. Right?
Oh, okay.
Why is that not right? So there's 5 carbons, so it's pentane, but it's a ring, so it's cyclopentane. Okay? That makes sense? Yes, ma'am.
I understand how to get the pentane and the octane and everything.
Octane, yeah.
Octane, sorry. But how do you get like C5 and how do you get the hydrogen 14? I understand how you get the carbon.
Well,
but how do you get
If I were to write the molecular formula for it,
Yeah.
well, because there's 3 hydrogens here and 3 here, and then there's 2, 4, 6, 8, 10, 12, plus 3 is 15, plus 3 more is 18.
You do that. Okay.
So C8, H, 18.
Okay.
I would just add them up. It's actually 2 times the number of carbons plus 2. Down here it says 2 times the number of carbons. So this would be C5H10. Because you don't, right? 2 times 8 is 16 plus 2. And here it says 2 times 5. But you can count them up. I would just count them up. All right, can you name these 4 then?
Butane.
The first one has how many carbons?
8. I mean, sorry, through 4.
4.
I'm sorry.
So 4 carbons. So 4 carbons is butane. Where do you find butane?
Lighter fluid?
Who's my smokers in the classroom? Who smokes? You know butane is a liquid in the glider, right? Smokers know that. All right, what's this one? How many carbons? 3 carbons. So it is propane. And it is a ring, so it's a cyclo, so it's cyclopropane. Okay? What about this one? This is octane, right? It's not a ring, so this is octane. What about the one at the bottom? How many carbons? 6. It's a hexagon, isn't it?
Hexane.
It is hexane. Cyclohexane, right? That's right. Do it in steps. Count the carbons. That tells you the base name. Then you look at it. It's a ring structure, so it's cyclohexane.
What was C again?
C is octane. There's 8 carbons there, right? 1, 2, 3,
Okay.
4, 5, 6, 7, 8. Yep. Okay. Okay. Those are easy ones. You gotta start easy, right? And then you gotta build up. No, you don't want to build up?
Nope, come on.
You just want to go home?
And just do this and make it perfect.
I'll just forget
Y'all are better than that.
Can I ask you to review something?
Sure.
When you were talking about the, you started on the rings, how you had that slide with a couple of the elements, back a couple more where one was,
Here?
yeah. What was that you explained about the bottom, why it can't be connected?
Why can't those 2 carbons just connect? They also have to lose the hydrogen, right? Because carbon can only have 4 bonds. It can't have 5 bonds. So if they just connect like this carbon would have 1, 2, plus 3, it would have 5 bonds. So it has to lose the hydrogen. That's why this is C3H8, and that one is C3H6. This it lost 2 hydrogens so that it can form that bond right there. because each carbon can only have 4 bonds. That's all it's saying, okay? You see that each carbon has 4 bonds?
I'm counting the line, I'm counting 3 bonds.
Well, this carbon right here has 1, 2, and then there's, if I were to put the hydrogens like this, you would see it, right?
Oh, okay.
Okay, so get rid of them right there. Then you see it as 4 bonds, right?
Yeah.
If you were to do it right here, it would have 5 bonds. Can't do that.
Okay, they would have 1 for each H.
Exactly.
Okay.
Yep.
All right, thank you.
Here's Herb. Okay, we've done the easy stuff. Now we gotta look at the molecules that are a little bit more difficult. Not a lot. Because alkanes are cool, and we use them to burn a lot of stuff, right? We burn methane, that's natural gas. We burn propane. We burn butane. We burn octane. And fire is good. I love fire. But it doesn't do a whole lot of chemistry. Let's talk something about molecules that have what we call substituents. They're a little bit different. Look at those 2 molecules on the right over there. Can anybody tell me what the molecular formula is for each one of those? What's the molecular formula for the one on top?
C3.
C3.
I'm sorry.
C.
H.
It's 10. What about this one right here?
C4H10.
This is also C4, H10. What? They don't look alike, do they? Okay, we're going to talk about why they don't look alike. Okay, these 2 are called, there's a special word for these, they're called isomers. I-S-O-M-E-R, isomer. They have the same molecular formula, but they have different shapes, don't they? And they're arranged differently. They have the exact same molecular formula, but they have different shapes. Now, if you're taking a biology class, you may remember that function follows form. You didn't learn that in biology class, that function follows form?
That was 4 years ago.
This lady's a dental hygienist, or going to be, right? Dental hygienist in training. Think about your teeth. How do your teeth work? You got big molars in the back, and you got your one in the front incisors.
Mm-hmm.
Look at me. Good.
He feels good now.
They have different functions, don't they? Why do they have different functions? So that you can eat better. And why are they shaped the way they are? Because they have different functions, right? If you tried to tear food with your molars in the back, it wouldn't be very efficient, would it? And if you tried to grind up some nuts with your front teeth, you ever tried 2 peanuts with your front teeth?
No.
Doesn't work too well, does it? Okay? So the chemistry of these molecules, because they're shaped differently, just like your teeth being shaped differently, are going to behave quite a bit differently. So we got to learn something about these guys. Okay? Fair enough?
Mm-hmm.
So, these are called structural isomers. They have the same molecular formula, but they're arranged differently, aren't they? Look at it. What's the name of this guy here? This has 4 carbons. This is, if I can write, this is butane. Oops. Dang it. This is butane. Now look at this guy. He still has 4 carbons. But this now is a form of propane. It is 2-methylpropane. We're going to talk about why that is in a minute. Okay? We're going to get to being able to name this. Suffice to say, the longest possible chain here is 3 carbons, right? I can't draw a line that will give me 4 carbons. Like here, That's 4 carbons, right? I can't draw anything here that gives me 4 carbons, can I? I could draw it differently than that. That's still 3, isn't it?
You have to go in a straight line. You can't go back.
No, you can't get crossed back over, no.
So you can't do like a triangle shape.
No. You can't go back through that carbon.
Your line has to stay continuous.
Yes. You can't go back. Okay? So this one has 4, this one only has 3. Okay? I'm going to do this problem for you because I figured out last class that they could do this. Here it asks, draw 3 possible structural isomers for pentane. The first one you guys should all be able to draw. Why? Because what's the first one? I'm going to leave the hydrogens off because it'll make it messy. Everybody okay with that being the first one?
Yeah.
That's pentane, right? Watch this. What if I take this carbon right here and I move it? And I do it like that. Everybody okay with that one?
Sure.
I still have 5 carbons, and trust me, there's still 12 hydrogens, okay? If you fill in, how many hydrogens would be on this carbon right here?
2.
This one right here,
One.
just one, why one?
Because it has 3 over.
It already has 3 bonds, right? So it can only have 1 hydrogen on it, okay? Now, the last one, is like that. Okay? Now, some of you may say, well, Dr. Powell, you could put that carbon over here like this. Right? And I'm going to prove to you that these two things are the same molecule. No tricks, I promise. We're going to name these guys. This one right here is what? This is pentane. Okay? Everybody agrees with that that's pentane. Now let's look at this one down here. I've got 1, 2, 3, 4 carbons. So that makes this butane. But it's still got something sticking off down here, doesn't it? This is 2-methyl butane. That thing sticking off down there is called a methyl group. 1 carbon is called a methyl group. We're going to get there. Okay? Let's look at this guy over here. Still only 4 carbons, so this is butane. Okay? And I had this sticking off. Now, this is still 2-methyl butane. You say, no, Dr. Powell, that carbon is on it. This methyl group is on a different carbon, isn't it? It looks like it, doesn't it? It's just flipped around. The molecule is just flipped around. Okay? It is the same molecule. The reason for that is you start numbering these carbons from the end over here, like that. And this one I would start numbering from over here. And we'll get there. We're going to talk about what these numbers and stuff mean. Okay? I just want to show you an intro to it. We're going to get there. All right. Can anybody predict what the name for this one's going to be? What's the longest number of carbons I have here? 3. So, what's the base name? Propane. Propane. And then I have